In this problem, we're going to do a hypothesis test about a population mean where sigma, or the population standard deviation, is known. So I'm going to go ahead and write on my paper here mu to remind myself that we're doing a claim, we're doing a hypothesis test about a claim about a population mean. And it's important for us to keep in mind that sigma is known. So anytime that sigma is known, that means we're going to use the normal distribution. And with the normal distribution, we're looking at z-scores, okay? All right, so let's read the problem and start writing down all the relevant information as we read. So listed below are the lead concentration measured in micrograms per gram of different Ayurveda medicines. Ayurveda is a traditional medicine system commonly used in India. The lead concentrations listed here are for medicines that are manufactured in the United States. So it looks like we have a small sample here of different lead concentrations from different medicines manufactured in the US. We are going to assume that sigma is 6.13, and we're going to use an alpha level or significance level of 0.05 to test the claim that, so let me highlight the claim. We're going to test the claim that the mean lead concentration for all such medicines is less than 14. Okay, so let me go ahead and write down the, use blue here. Okay, so let me go ahead and write down the original claim using symbols. So we're saying that the mean lead concentration is actually less than 14, okay? All right, so looking at the original claim, we notice that it does not contain equality. So we know that that's not going to be the null hypothesis. So what we do is we ask ourselves, if this statement is false, so if this is false, meaning if mu is not less than 14, then what else can mu be? Then we can say that mu could be greater than 14, or it could be equal to 14. So I'm going to break that down into two mutually exclusive statements. And then what we're going to do is we're going to take the one that contains equality. That's going to become our null hypothesis. So let me go ahead and write down the two hypotheses. Okay, so our null hypothesis becomes mu equals 14. And our alternative hypothesis is the original claim. So the original claim becomes our null hypothesis. So because our null hypothesis, or excuse me, our alternative hypothesis, excuse me, the original claim becomes our alternative hypothesis. So because our alternative hypothesis has the less than sign, we know that we are looking at a left tail test. So I'm going to draw the normal distribution here so we can visualize this problem. So left tail test gives us this region here is our significance, is our alpha. So this has an area of 0.05. Okay, that's this region here. And we call this blue region, this is called the critical region. So this is called the critical region. And what we can also do here is we can find the critical value that separates that tail end on the left from everything above. So to find the critical value, that critical value is z sub 0.05. Just go to your calculator and use inverse norm. We're going to type in 0.0501, and it will give you that critical value. So because this is to the left of the center of the distribution, we know that critical value is going to be a negative value. So let me go ahead real quickly and put this into my calculator. And that will give us negative 1.65. Okay. All right. Let's continue on. So we're going to continue with the hypothesis testing by using our calculator. So on our calculator, we are going to use the z-test. At the end of the video, I'll show you what this looks like on your calculator. The z-test is going to give us the test statistic. Recall that the test statistic is a z-score for our sample statistic. So in this problem, the sample statistic is, we don't have it yet. We need to go and find it. So I need to get all of the sample statistics for our data here. So to do that, you're going to go to your calculator and do one variable statistics. Okay, so you're going to type all that in into a list and then go to, so I'll put it into like L1, my list, my first list, and then go to your calculator, press stat, and then choose one variable statistics. Okay, so after we do that, the calculator will give you 11.05, and the sample standard deviation is 6.46. And let's write our unit down here so we don't forget the units. Okay. And also I'm going to write down here our sample size. So there are 10 values in this set. So we have a small sample, but that's okay. So n is 10. And now I know what my sample statistic is. It's x bar. I can go and do the z-test and find the test statistic. So the test statistic is a z-score for x bar. So the z-score, what we get for this is negative 1.52. Keep in mind that it makes sense that it would be negative because we have a left tail test here. And our calculator also gives us a p-value of 0.064. Okay, so let me shade and mark all of these things on the graph so that you can understand what this is. So a test statistic, I'll use green for it. Hopefully you can see that the test statistic, negative 1.52, is probably somewhere over here. Okay, negative 1.52. So hopefully you can see that it does not fall in the critical region. So we would make the conclusion that since our test statistic does not fall in the critical region, we are going to fail to reject the null hypothesis. Okay, so if you're using the critical value method, that is the conclusion that you would make based on the fact that our our test statistic doesn't fall in the critical region. Okay, now I'm going to use yellow to highlight the p-value. So the p-value is, and I'll use yellow here to highlight it, the p-value is the probability of getting a value that is at least as extreme as the one that we got. And the one that we got, I'm referring to our z-score of negative 1.52, which corresponds to our sample statistics of 11.05. So what this is saying is it is saying that the probability of getting a value that is at least as extreme as ours is larger than our significance level. So if you're using the p-value method to make a conclusion, we can say since our p-value is greater than alpha, or 0.064, so hopefully you can see here, and let me mark that. This yellow region has a p-value of 0.064. Okay, so 0.064 is greater than 0.05. Then we are also going to fail to reject the null hypothesis. So it doesn't matter which method you use, you're going to come up with the same conclusion. And now the last thing that we're going to do is we are going to write our conclusion in a complete sentence. So let's do that. So we would say that there is not sufficient evidence to support the claim that the mean lead concentration for all such medicine is less than 14 micrograms per gram. Okay. Below, I'm going to link other videos to more examples on hypothesis testing about a population mean when sigma is unknown, and also how to do hypothesis tests about population proportions. But before we exit, let me show you real quickly how to do that z-test on your calculator. So on your calculator, this is what it looks like. You are going to go to stat, or excuse me, yeah, you're going to go to stat. And in stat, you're going to edit, and under edit, this will come up and you can start typing in your data. After you have all your data typed in, you're going to go back to stat, and then you're going to choose calc. And under calc, you'll choose one variable statistics. And that will give you your X bar, your sample, and your sample standard deviation. Okay, so for this problem, that was the 11.05 and the 6.46. Okay, to do the z-test, you're going to go to stat, and you're going to press this button, test, okay? And then you're going to choose number 1, z-test. It's going to ask you to put in some information. So you want to type in, now the difference here is you're going to type in data instead of stats. So we don't have the statistics yet, but we have data. So you're going to choose data, put in your mu naught, put in your known sigma, choose the list where you typed in your data. This last line here is asking you to put in the alternative hypothesis and then press calculate. And when you do that, these are the results from our z-test. So notice you've got your test statistic here and your p-value below. Okay, that's it.